Here we are again, another great fraction lesson, multiplying proper fractions and mixed numbers. I would like for you to read the comic, of course. Baby Blues is one of my favorites. As you can see, their parents are dreadfully worried. What if Hammy never gets fractions? Well, we don't want that to happen to you. So I want you to take a minute to read through the first 2 pages. Just kind of walk through that a bit, and I'll be back with you in a second. All right, well, I guess you already read the good news. Multiplying fractions is so much easier than adding and subtracting. None of that common denominator, no need to rewrite the fractions. You just get to jump right in and get busy. It really is going to be imperative for multiplying and dividing, which we'll get to shortly, that you must show your work horizontally, not vertically. Not even an option here. Well, so I just put a really simple one up here. Now they just happen to have the same denominator, but they don't need to. You really just multiply straight across and then simplify. So by straight across, I mean you're multiplying the numbers in the numerator together and then the numbers in the denominator together. I kind of added this step sort of optionally. Of course, you can just look at it and multiply 3 times 1 and 4 times 4 to get 3/16. Don't even have to simplify that one. So that one, that's about as easy as it gets right there. Well, often it doesn't work out quite that neat and tidily. So it usually works best to simplify before you multiply across, which sometimes can't even be done, like in the example we just had. But when it can be done, it prevents a lot of unnecessary scratch work, and I call that process dividing out. Some educators call it canceling. To me, canceling is -2 plus 2 equaling 0. These two numbers cancel each other out to come up with 0. So dividing out more appropriately fits the description. If you have something like 3 over 3, and you say, well, 3 goes into itself once, and it goes into itself once, we've just divided out. But when you divide out, you get 1. You don't get 0. So that's the reason I don't call it canceling. But if you're working with a tutor or a sibling or a parent, they may call it canceling, and that's fine. Just know that I'll be calling it dividing out. The option, well, it's really not an option to divide out. You absolutely have to learn how to do it. As I wrote here, don't leave home without it, without this skill when you're working with fractions, because that's going to make your life harder. And we always want to work toward making life easier mathematically, not more challenging. So I've taken this one problem on page 2, and I've shown you what happens if you don't divide out. So the left side, multiplying first and then simplifying, this is the long way without dividing out. This is the way that it requires more scratch work generally. So let's just walk through this side first, and then we'll jump over to the right side. So if you just multiply straight across, you would just 6 times 21, 7 times 30, and you would get this fraction. Well, then you have to go through the tedium of simplifying. You have to think about your divisibility rules, or you do long division out to the side. Now, I just wrote these yellow, I highlighted some of the steps in yellow just to make the notes easier to follow so you could see where my next step was coming from. You don't actually have to write that step, and actually I would prefer it if you didn't, but I wanted the notes to make sense. Well, so I divided the numerator and denominator both by 2, then both by 3. Now remember our divisibility rule for 3. I knew that 5 and 1 and 0 adds up to be 6. So 6 is divisible by 3, so I knew 105 was divisible by 3. Then I got 21 over 35, and I realized, oh, hey, 21 is divisible by 7, and so is 35, and I got 3/5. Now I put the thumbs down because that is not really a very efficient way of working the problem. So instead, from the very beginning, you save yourself a lot of time if you go ahead and multiply or write out the multiplication straight across, like I did here. But notice how I rewrote it when I got to this second step. So I said I'm going to line up the values with their common factors. So I kept the numerator the same. So I still have 6, I still have 21, but in the denominator, I did have 7 times 30. I switched it and put 30 times 7, which is completely legal. It still equals the same thing, but that makes it a lot easier to view. Now I'm kind of looking at this as sort of a separate fraction, and this as a separate fraction. So if you simplify the one on the left in red, 6 over 30, it's easy to see you get 1/5. And then 21 and 7, you could just divide 21 by 7 and put a 3 on top and leave this 1 off altogether. It doesn't have to be here. Or I just thought it might make a little bit more sense if I just divided the top and bottom both by 7. Then you could see, now if you multiply straight across, you get 3/5. So really, I wrote in, this is an extra step. Really, you would just have this right here, and from there, I'd go straight here to my result. So that's the thumbs up, because that is the way to do it. Now, sometimes when people multiply fractions, they do what I call slashing. Okay, they call it canceling. I'm dividing out without making any slashing. When you do that, it really creates an unreadable problem, and that causes errors, and I suggest you avoid it. I'll show you what it looks like, because likely if somebody helps you, they may show you a problem like this. So let me take this problem that I had, just so you'll know when you see it. One thing we could have done in this problem from the very beginning is we could have simplified the 21 over the 30, and we could have divided both of those by 3 and moved on from there. In fact, I'll do that because I can still show you the slashing, so to speak. So if I keep 6/7 and I simplify, so 21 divided by 3 is 7, and 30 divided by 3 is 10. Here's what slashing kind of looks like. People will say, oh, well, 7 goes into itself once, goes in here once. Now, I'm using another color. That makes it a lot easier. And then they'll look at something on top with something on bottom. They don't have to be diagonal from each other, but they often are. 6 is divisible by 2, and 10 is divisible by 2. Now, to me, you've just kind of created a mess. But if you do it that way, I can't really stop you if you're consistent, but I will ask you not to scratch things out. So if you multiply across, you'd have 3 times 1 and 1 times 5. You'll get the same result we did before. And I might mention, this is extremely common. This is most likely what someone else helping you that hasn't been teaching math for 30 years will show you. I used to teach it this way too. I just noticed that it caused a lot of problems, so I stopped doing it that way and tried to teach students a better way. But it's legal, it's okay, but your problem still needs to be readable. So make sure, if you're not using a different color, I would suggest writing the numbers below like I did, or above. So maybe skipping a little line so that you can write above. And you really have to spread out your work, and not, you have to be particularly neat if you're slashing. And slashing is not really an official math term. That's just a little Miss Shaw-ism right there. So, this is Wile E. Coyote from from Roadrunner. If you've never watched the Roadrunner cartoon, you should check that out too. But using the video, you should use the video to work through these examples before going it alone. So I wouldn't try these alone because I really want you to utilize what I was just telling you about simplifying. So I've kind of just given you a little box of how I prefer to do it, and we'll just walk through one of these together while the rules are up here. So write both fractions as either a proper or improper fraction. So if you have a mixed number, you have to convert it. So if you convert a mixed number, of course, it's going to be improper. So 3 times 5 is 15, plus 4 is 19 over 5, times 2 and 5 6 is 2 times 6, 12, plus 5, that's 17 over 6. Remember, you don't need a common denominator when you're working with fractions. Now, if I was going to rewrite this one, if I'm going to multiply across, and write one big fraction, that's what I put as step number 2. Write one big fraction multiplying across in the numerator or denominator. At the same time that I try to do that, I usually just keep the numerator in order, and then I look at the 5 and the 6 and think, does either one of those have anything in common with 19 or 17? And they actually don't. So it really doesn't matter what order I write them in. There's nothing in common. I can't simplify 19 fifths or 17 sixths, so I just have to multiply straight across. Unfortunately, on this one, I'd have to do a little scratch work, and for time purposes, I'll just write down the result. But I'd have to go over to the side and multiply 19 times 70, but actually, it just occurred to me, one quick way you could get it is you could think of 20 times 17, that'd be 340, and then you only had 19 17s, so you could take 340 and subtract 17 from it, and that would give you 323. Well, you may or may not find that any faster. Well, for 323, you might look at it, see if it's divisible by any of the numbers that 30 is divisible by. It's not divisible by 10 or 5. If you add up all the digits, you get 8, so it's not divisible by 3 or 6 or 2. So it's finished. Now, if you wanted to convert it to a mixed number, you could, but that just opens up the door for more error. So typically in algebra, we work with the numbers as improper anyway. So since it came out as improper, there's really no point in converting it back. If you do choose to convert it, I will grade your conversion, and so you need to be accurate with it. So that one had no dividing out. So I'm just going to make a note over here. Not every multiplication problem involves simplifying. Remember, dividing out is just simplifying before you get to the end. So 2 and 8/15 is number 4, and times 5 and 5/14. So a common mistake is a student wants to multiply 2 times 5 and get 10 at the very beginning. Well, remember, you're not just multiplying the whole numbers. You're saying, I want 2 and 8/15 not only 5 times, but 5 and 5/14 times. So you have to go through the same rules that we've listed up here. Write them as improper. Then we'll make one big fraction, and I think we're going to be able to simplify on this one. So let's see, 2 times 15 is 30, plus 8, that's 38/15, times 5 times 14 is 70, 70 plus 5 is 75. Keep your denominator. So now I notice, okay, I see a couple of numbers that end in 5, so I'm going to make my big fraction, keep the numerator in order. You can either put both numbers in the numerator in parentheses or just one. You could use the multiplication dot if you prefer. I just put the second number in parentheses. And the 15 I want to be under the 75 because they have 5 in common, at least. And 14 I'll put under the 38 because I notice they're both even, so I know they're both divisible by 2. So I'm going to divide the numerator and denominator by 2 for the first fraction. That's second fraction, 15 actually goes into 75, but you might not notice that. So if you recognize, oh, they both end in 5. If you divide 5 into 75, we're going to get 1. Oh, I'm going to get 15. Yeah. 5 times 15, of course. And 5 into 15 is 3. Now notice, don't write just 7, write it right next to a 3. You've got to actually put one of those numbers in parentheses. So 15 over 3 is still able to be simplified. So I'm going to just kind of move up here. This is what I would do if I were you, if I was at the bottom of my paper, kind of move up and come over to the other side. So I keep the 19 over the 7, but on top I have 15 divided by 3. So 15 divided by 3 is 5. I don't really have to put a 1 on the bottom, but of course I could. I won't. Now I'll just multiply 19 times 5. Think 20 times 5 is 100, so this is only 19 5s, so that would be 95 over 7. 7 does not go into 95 because if we use our divisibility rule for 7, double 5, that'd be 10. 9 minus 10 is -1. 7 doesn't divide into 1 evenly, so it's 95 sevenths. So if I were you, at my recommendation here, I would try the next 2 on my own and then come back to the video to not only verify your answer, but to verify your process. Okay? See you back in a minute. Welcome back. So let's convert these to improper. That's our step 1. 3 times 18 is 54, plus 1 is 55 18ths. 2 times 33, 66, plus 2, that's 68 over 33. So you make your one big fraction, and you try to rearrange a little bit. Again, I usually just keep the numerator in the same order, and then I notice, oh, 33 could go under the 55 because they both have 11 in common, and 18 is even, at least, so I know I can divide 68 and 18 by 2. So divide both of these by 11, 55, it becomes 5. 33 divided by 11 would be 3. If I divide 2 into 18, I get 9. If I divide 2 into 68, I'll get 34. Now at this point, just look again and make sure there's not still anything in the denominator that will divide evenly into anything in the numerator. 3 doesn't go into 34, 9 and 5 don't have anything in common, so all I have to do now is multiply straight across. So in the denominator, I get 27, 5 times 34, let's see, that is 170. I take a look at 170, I think about my divisibility rules. The only factors of 27 are 1, 3, 9, and 27, and 3 doesn't go into 170 because 1 plus 7 plus 0 is 8. That's not divisible by 3, nor 9. So unless 27 goes into it, it does not divide into it evenly. So you might try that, but it doesn't go evenly. So that's our answer. Okay. Let's try another one. Notice on this one that 4 over 16, you could make your life simpler if you simplified that at the start. If you don't, it won't cause you to miss the problem. It will just cause you to have larger numbers and a little more simplifying to do. So I'd rather call it 1/4. And now convert. So 2 times 4 is 8 plus 1, so 9/4. 1 times 25 is 25 plus 2, that's 27. Now you look, and if you keep 9 times 27 on the bottom, nothing really has anything in common with anything, so I could just leave them the way I have them, and then I'll have to just multiply straight across. Oh, you know what? I'm sorry, I changed this problem on your handout and it's not changed on my notes. Let me erase this one. I'm sorry. I changed it because I wanted it to be a little one that you could actually do dividing out. Let me write the right problem up here. Sorry about that. That number should have been a 2. It's 2 and 4/16 times 2 and 2/25. All right, let's try that one more time. There's still my 1/4. So I'm going to go back. That's still 9/4. But now it's 52 over 25. And now I actually do have something in common. 52 is divisible by 4. Now, if you don't play very many cards, you might not recognize that. That there's 52 cards in a deck, and there's 4 suits, and each suit there's 13 cards. So I'm going to put my 4 here and my 25 under the 9. Let's go down. Extend that page a bit. Okay, now let's simplify. So I'll keep the 9 over 25. They have no common factors other than 1. But 52 is divisible by 4, and it goes 13 times. So now I can just keep my 25 on the bottom and multiply 9 times 13. 9 times 3 is 27. Carry the 2. 9 times 1 is 9, 10, 11. And 25 only has factors 1, 5, and 25, none of which go into 117, so it's finished. As you can see, you really still have to know those divisibility rules. So again, you could try the next 2, except the next 2 problems, you could try them on your own if you want to, go ahead, and then you can come back. But this one just has a whole number in it, 2. And you can also simplify 3 over 72. Remember, 7 plus 2 is 9. 9 is divisible by 3. And I've got a lot of examples on this one, but I think they're going to be important. So I'll just write 2 as 2 over 1. 3 goes into 72 24 times. So now let's rewrite 6 and 24, 1 over 24 as a mixed number. So if I multiply 6 times 24 and add the 1, let's do that out to the side. 24 times 6 is 24. That's 144 plus the 1. That's 145 over 24 times 2 over 1. I'm going to make the one big fraction. And I'll put the 24 over here under the 2, since they're both divisible by 2. So now I have 145 on top, and 2 goes into itself once, and 2 goes into 24 12 times. And so 145 over 12. I know 12 doesn't go in there evenly, because 144 is divisible by 12. 3 doesn't go into 145, 4 doesn't, 2 doesn't, so 6 doesn't, so it can't be simplified any further. Let's try this last one. I know this is a long video. Hang in there, we're almost done. It's a good half hour of your life. You never waste time. It's never a waste of time to learn something new. So 6 times 15 is 90, plus 1 would be 91. So now you want to make the one big fraction. This is when you start kind of rearranging. Now remember, when I say rearranging, you can't take something from the denominator and just shove it up in the numerator, or the numerator and drop it down into the denominator. You can only rearrange the order within the numerator or denominator that you're multiplying. So we're really just going to put the 15 under the 5, and the 26 under the 91. Well, 5 over 15, divide both by 5, you get 1/3. 91 is one of those numbers people like to think of as prime, but apply your rule for 7. If you double the 1 and subtract it from 9, you get 7. So we know 7 is divisible by 7, so 91 is divisible by 7. And it actually goes 13 times. Oh, sorry. So we don't want to write 13 because 7 doesn't go into the denominator. But 7 times 13, and 13 goes into 26. Sorry. So it goes twice here, and it goes 7 times here. Again, there's nothing up in the numerator. Say, for example, maybe you got a 6 right here instead of a 7. Well, then the 3 would go into the 6, but that didn't happen. So multiply straight across. 7 over 6. Clearly, you cannot simplify it any further. Just a little encouragement, a little motivation down here. We have to be fierce with fractions. We have to keep the math spirit alive. Don't let anybody turn you into a fraction phobic. Be friendly with fractions. Be fierce. Go forward and conquer.